Okay, let's talk about perfect combustion versus complete combustion. Perfect combustion is also known as stoichiometric combustion. That's the last time you're going to hear me say the word stoichiometric, because it's not a term that we usually use in the field. But what perfect combustion is a chemical term. It means that we've converted that fuel into carbon dioxide with zero oxygen left over. And it's the highest efficiency of combustion that you can get. The problem is it's not realistic. In the field you have variables, and if you're only providing just enough oxygen to burn all the fuel and convert it into carbon dioxide with zero oxygen left over, if anything changes and you don't have enough oxygen, now you have incomplete combustion. So the manufacturers of equipment on purpose build in a safety factor, introducing additional oxygen into the combustion process so that they ensure that we've converted that fuel into carbon dioxide and not carbon monoxide, which is bad, as we all know. So when you're performing a combustion analysis, complete combustion is what you're shooting for. And what that means is you're going to have converted that fuel into carbon dioxide. You're going to see some oxygen left over in your vent pipe, and that's okay. And you're going to have very little carbon monoxide. Carbon monoxide is measured in parts per million. And if you read more than 100 parts per million in your vent pipe, then you're supposed to investigate further. That's not normal. If you read over 300 or perhaps 400, depending on which jurisdiction that you work in, you're supposed to red tag the equipment and shut it down. The reason is because when that vent pipe is spewing out that high concentration of carbon monoxide, it may not get diluted in the outside air before it gets introduced back into the building or for other people outside to breathe, so it's not safe. Also, typically when equipment is burning at over 300 parts per million, soot is going to start developing, and that soot is going to create more carbon monoxide, and that carbon monoxide is going to create more soot. So you don't know any of that information unless you're doing carbon monoxide testing and combustion analysis. So if you're a supervisor, a manager, an owner in a position to make those kinds of changes in your company, then please invest in the equipment, in the training, learn about combustion analysis, teach your technicians about it. Do that on every heating PM. You'll be surprised what you'll find when you have that extra information. Simply looking for a blue flame and 3.5 inches water column manifold pressure is not enough information. Performing combustion analysis can be a sales tool. You're going to find problems with that furnace. You're going to find problems with your heat exchanger that you never would have before. So I hope that this quick video has been helpful. Please be safe.